Alright, so what you're looking at is my finished version of the 5-line puzzle logic game. So previously I showed you an online version in an earlier version of my game, my version. So I finally finished it. And let me just play through. So right now it's just one screen and I fit everything into it. I don't plan on creating any menus or anything else. It's all really simple and it doesn't need to be complicated. So the objective of the game is to connect 5 balls in a row in any direction, and let's try and do that. So what I'm doing is highlighting the ball I want to move, and using the arrow keys, I move the crosshair to the new location and I hit enter. It draws a little path to the new location. And let's keep going. I'll try and make this fast. So the objective is to create as many lines as possible without the board filling up so that you can't do anything. Let's see if I could connect one line. We're getting close. There we go. And if you notice right here, under the score, it says 5 times 10. So basically the point system works by the longer the line you create, the more points you get per ball. So if you do 5, you can only get 10 points per ball. If you do 6, you get 20. If you do 7, you get 30, and so on. And let me just keep playing a little more. So this can take a while to do, but I'm going to enable the cheat mode. So if you notice right here under the things we can do, this was more of a debugging function that I added in, but I figure I'll leave it in as a cheat mode. So in order to test the various scenarios, I needed a way just to plot down any combination of balls I wanted and check the algorithm to make sure it was working. So if we hit C, we can see now that keys 0, 1, 2, 3, 4, 5, 6 are enabled. So what that means, I can move the crosshair around, and if I hit 1, I could plot red balls. So let's say I wanted to test my algorithm for finding more than, let's say more than 5 balls connecting. So let me just plot one more there. I'll select it. And now if I move it, we can see the multiplier here is 7 times 30. So there was 7 balls that connected and 30 points for each one. So I've left that in there as you don't need it to debug anything, but you could use it to basically cheat. So if you find that you're running out of space and you need to free up some balls, you could hit the 0 and remove some. And you could toggle the cheat mode on and off. So if you hit the C again, it toggles that. And if you get bored of the current game, you could always restart. You hit R, and there we go. We start all fresh, score wiped out, and that's basically it. So this version works with DOS. I'm pretty sure it could work with Windows. I just haven't had time to test it. So first release DOS Go32 platform. And let's take it the code. Let's look at the code here. So it's roughly, let's see, we got almost 1100 lines in the main, and in the one of the units, another close to 100. And this one, another 250, let's say. 250, 350, roughly around 1,500 lines of code. So there's no external graphics or anything. Everything is done using the built-in graph commands. And you can easily change the attributes here. I've left a lot of constants. So we can change the size of the ball here. Instead of being the radius being 10, we could change it, make it smaller or bigger. We could even change the grid size. So it's 9 by 9 by default. But you can change this to something else. You'll have to adjust the screen, but I've left all kinds of procedures that allow you to basically change this to a different resolution and readjust. So you can move the main game board to a different area, the help menu and the score menu. So if you decide to use a different screen mode, you can adjust these and make everything line up properly. So there's a lot of code here, but the most interesting is probably the pathfinding code. I've done previous videos on how to use this. This is a trimmed down version to work with this type of game. So you may find it useful in another kind of logic game where you need pathfinding. And if you modify it a little, you could use it for other purposes as well. It's pretty straightforward if you read up on pathfinding. If you just go ahead, then it might be a little confusing to what I'm doing here. But basically, if you think of pathfinding by laying out breadcrumbs to every destination and do a follow back, that's how my algorithm works. There's other published algorithms that are slightly more complicated. You can look up A-star algorithm and Dijkstra's pathfinding algorithms. They're a little more complicated, but there's a lot more documentation. If you're interested, you can look that up. Anyway, that's it for this video. Check out the code. Let me know what you think. Leave a comment and all that stuff. And thanks for watching.